Well, good morning, everybody. It's Miss Pollock, and I get to talk to you about ramp problems today. This is so much fun. Those of you that love math are just going to be so excited, and I'm excited because it's actually sunny outside. So, let's get started. I have a 80-kilogram box placed on a 20-degree incline, and the friction force is 5 newtons. So, I'm going to start with a interaction diagram. So I have a box and it's interacting with the earth and it's interacting with the ramp. Not only is the ramp supporting it, but there's also a friction force on the ramp. So also I want to draw a picture. Here is my 20 degrees. Here is my box. All right, and it's on my ramp. What I like to do first is to just draw the forces right on the picture so I know what's going on. So I know that my gravitational force is always towards the center of the earth. I know my normal force is always perpendicular to my surface. That's why it's kind of at an angle there. And I know my friction force is along the surface. Okay, so if you look at those, that looks like a mess. We do know that since the normal force is perpendicular to the surface and the friction force is parallel to the surface, that this right here, that's 90 degrees, right? They're perpendicular to each other. So what physicists do is they reorient the free body diagram. And what I mean by that is we always put the normal force straight up. So I have taken my free body diagram and I have rotated it this way. So the normal force is up. So the friction force is now 90 degrees from that. So the friction force is going to be horizontal. And now I've rotated my gravitational force 20 degrees, so my gravitational force is down at an angle. So to recap, my normal force is always up, okay? I rotated my friction force 20 degrees to make it horizontal. So if I rotate everything 20 degrees, then that means my angle from the horizontal for my gravitational force is 20 degrees. So gravitational force is 20 degrees from the vertical. Physicists always find a way to make things a little easier. Okay, so now you see that I don't have components for a normal force or a friction force. I just have components for my gravitational force. So let's see what they look like, what that looks like. So here is my normal force. Here is my friction force. Here is my gravitational force. So I can have components. Remember components? I can split any force that is at an angle into a vertical and horizontal component. I'm going to call this component my gravitational force that's perpendicular to the surface. So Fg perpendicular, that's the component of Fg that is perpendicular to the surface, the ramp in this case. This right here, my gravitational parallel. So Fg parallel is the component of Fg that is parallel, let's see if I can spell it right, to the surface. Okay, so we can take a look at this, right? And we can say a couple things. We can say that my normal force and my gravitational force is perpendicular to the surface. Those two forces are balanced because my object is not going into the ramp or up off the ramp, right? So those are balanced, okay? We can also say that in this case, because I know my block is accelerating, that these two forces, my friction force and my gravitational force parallel, are unbalanced because the gravitational force that is parallel to my surface is what's pulling it down, all right? So let's just say that the gravitational force that is perpendicular and my normal force are both perpendicular to the surface, and my gravitational parallel is pulling the box down the ramp. If there was no friction, it'd be pulling it down more. Now that there is friction, it's not accelerating as much. Okay, so now we need to determine the value of the normal force. Well, let's, first of all, let's find the gravitational force. We've done this before. Gravitational force is mg. So gravitational force is 9.8 newtons per kilogram times the mass, which is 80 kilograms. So my gravitational force is 784 newtons. So let's take a look at this triangle that we have. This is my gravitational force. And these are the two components of my force. That's my gravitational force perpendicular and my gravitational force parallel. All right, so here comes some trig. So this side of my triangle, okay, cosine of 20 degrees, because remember this is where my 20 degrees is adjacent over hypotenuse. In this case, cosine 20 degrees is my perpendicular component of my gravitational force over my gravitational force. I can do some math now. The perpendicular component of my gravitational force is Fg times cosine 20. So the perpendicular component of my gravitational force is 784 times cosine of 20. So the perpendicular component of my gravitational force is 737.7 newtons, which we already said was equal to my normal force. They're balanced because they're both perpendicular to the surface. All right, let's do this leg. This leg, we know sine of 20 is opposite over hypotenuse. So sine of 20, sorry, I'm just so excited. I love this stuff. Sine of 20 degrees is my gravitational force parallel divided by my gravitational force. So my gravitational force parallel to the surface is Fg times sine of 20 degrees. And when I calculate that out, that ends up being 26.8 newtons. This right here, this is what is pulling the block down the ramp. All right. We found the normal force. Yay, we found the normal force. And now it says determine the acceleration. Well, let's go back. Let's look at the free body diagram. I'm going to redraw it for you instead of scrolling back up. So here's my normal force, 737.7 newtons. Here's my friction force that I gave you to be 5 newtons, right? Here is my gravitational force, 784 newtons. My components, we've calculated those. We know that my gravitational force perpendicular is 737.7 newtons. Remember, those two are balanced. The gravitational force is perpendicular to the surface and the normal force perpendicular to the surface. But what is not balanced are these two forces, the friction force and my parallel gravitational force. Those are unbalanced. That is what is making my object accelerate. So the first thing I need to do is I need to find my net force. And my net force is the gravitational force that is parallel to the surface minus my friction force. So my net force is 26.8 newtons minus 5 newtons. So my net force is 21.8 newtons. And we know acceleration is net force divided by mass. So 21.8 newtons divided by 80 kilograms. So my acceleration is 0.27 meters per second squared. How fun is that? Okay, you guys have a great day, and I hope the sun is shining on you.